Here we are sitting in the thermal laboratory of ESTEC. We have a lot of vacuum chamber where we are able to go from minus 250 and up to plus 200 and even more. And a lot of JUICE hardware has been qualified here, or thermal performance of the hardware has been tested here. JUICE is very special because on the way to Jupiter we go much closer to the Sun than the Earth is, and we have this Venus flyby. But in very beginning of this year, 1st January, we went even closer to the Sun with what we call the Sun closest approach, and we had 3,320 watts per square meters of sun flux. So that's more or less 2.5 times more than on Earth's vicinity. So the thermal control has to face both this very hot environment but being able to withstand the mission in the very cold environment. On JUICE we have a huge antenna. The size of the antenna is meant for communication from very far away to the Earth, but it's located on the side of the spacecraft where during all the cruise in the inner solar system, that is between Earth and the Sun, close to Venus for example, we use it as a thermal shield to shadow the large part of the platform. Venus is fully covered with white cloud, and it reflects 80% of the sunlight, which means that when we pass between the Sun and Venus, the spacecraft will have all this reflection of solar flux from the backside. That's a bit unique to what happened during the Venus flyby. We have here 2 years of temperature measured on the JUICE high-gain antenna. Starting really from launch, 20 degrees in Kourou, and then we have a first approach from the Sun, then come back to Earth flyby. And in 1st of January we experimented our Sun closest approach, where we reached temperature slightly above 150 degrees. And now we are going to be a bit slightly warmer with the Venus flyby, but for us we have already experimented the hottest temperature possible on JUICE, and particularly on the high-gain antenna. JUICE is completely surrounded by these blankets. We have in total external layers 50 square meters of such blankets. The coating is very specific. It's called StarMet. It's a coating mainly based on silica that keeps the electrical conduction, which is very important for JUICE, particularly for the electrical plasma magnetical experiment that we have on board of JUICE. So we need to conduct all the electrons, all the electricity, but what we want as well is to reflect the sunlight as much as we can, and this coating allows this. Most of JUICE MLI are made of these 25 layers multi-layer insulation. All the layers are made of Kapton with, you can see this shiny coating. This is aluminum deposit on both sides of a very thin polyimide film. And between each film we have another layer of polyimide fleece that create another insulation. So in total we have 25 of this plastic film with 24 of these insulation, so 50 layers. And this is just a few millimeters. Just imagine, it can be 200 degrees there and 20 degrees on the inside. Very efficient. A part of the spacecraft, the backside, which normally is never sun illuminated, is made with this black Kapton coating. This one is also around 20 layers. So this one is lighter, a bit less efficient, but this one is mainly made for the boom, which can withstand very high variation of temperature without any degradation of the performances. I often compare the thermal engineer as high fashion clothes, because we do something very fancy, very shiny. It costs a lot, and that's what we see from the spacecraft. And sometimes we need to be able to build some origami to protect some different shape. So we start from something flat, because this is how the blankets are built. But on the spacecraft you need to have a specific shape. Sometimes for some antennas we have also some very fancy shapes. So just imagine that here we have just one small antenna that needs to protrude, and we need to protect all around. I think we have more than 500 of these blankets on JUICE. So just imagine the work, the hours for making this.
Twice a year we have what we call a science working team meeting to discuss the important aspect of the project and to meet, to take the decision. To take a decision, it's always good to be there, to discuss collaboration, what we need to do together. And what is important is that we have the teams now, and they will not be necessarily exactly the same team in 6-7 years. Okay, we expect that the bulk of the team will be the same, of course, but there is always new people coming, people leaving the project, they retire or they go to another project, young people arriving, doing their PhD, training and so on, engineers. It's important that we meet, we keep the connection between all of us to prepare what needs to be done in a few years, to keep the knowledge, and to pass the knowledge to the people who need to get this the information. So yes, the human aspect, I think it's very important to make sure that we work as a team in the end.
We're in the middle of the very hot cruise phase, getting as hot as it gets right next to Venus. So precisely as I am, getting as hot as I can get, no more than this. We're getting very close to Venus, so everything has to remain as cool as possible on board. So we're doing a little maneuver to get us on track to Jupiter, but nothing else. This morning when I woke up at 9, I thought, okay, here comes my 24-hour day now, because we're gonna be in the station just to be witnessing the event. The station will be tracking JUICE for a good 9 hours.
We are in Cebreros Station, which is one of the deep space stations that ESA has around the world. We're with Malargüe in Argentina and Inertia in Australia. The station belongs to the Ops department in ESA, and this is located in the city of Darmstadt in Germany, in ESOC, European Space Operations Center. There we have all the control centers for all the missions, but also we have what is called the Network Operations Center, which is a control room where all the stations on the S-track stations are controlled. Then the signal that we receive here is at the end sent to ESOC, to this network control center, and then to the dedicated control room for emission, in this case JUICE.
For every mission, there is always this issue on how to manage the memory on board, because one of the memory on board is actually the memory linked to all of the observation we are going to make. So picture of Jupiter's, spectrophotometric data, or any other kind of data that are recorded by the instruments. And those data can be quite heavy, so take a lot of space in the memory actually. And so we have to monitor this memory to be sure it doesn't overload. And also we have to predict how much is going to be overload a long time, because we have a lot of constraint on that. We have to know the memory status in order to let the instrument record the data. It is important for every mission. It's not only my mission, it's a problem that is coming in every mission. So I feel like I'm learning a lot from this. And also sharing this moment with all the people that are working on this. I know it's a change, definitely.
We are now today in the date of the Venus flyby of JUICE mission, and in fact here in my back, in the middle of sunrise, so we have Venus and Jupiter, and JUICE is now so close to Venus. We are even watching with a telescope Venus and Jupiter, which is a nice opportunity to see the two things together. The antenna started tracking JUICE around 1 hour ago. Then everything is looking well. ESOC is acquiring the signal from the station and everything looks nominal.
So yeah, how's it going in the past?
No, we saw the antenna moving, that was great. Just after the signal, the telemetry arriving, so it's fantastic. And on your side, how is the spacecraft doing?
All good. We are 45 minutes before closest approach, and yeah, everything is really nominal. We had AOS, no problems, no issues, and okay, we're waiting. There's like in half an hour we start with Star Trek blinding, so we'll be blinded by Venus. Yeah, let's see how this is looking like. So we are monitoring this, and then also, I mean, Venus will come on the backside. Probably there will be some outgassing. And as Venus is pretty bright, it's probably going to be more outgassing. But okay, the panels are not on, they don't notice.
How is the ambience in the team?
Damn it. I can show you, huh? So it's... Yeah. So basically we have full team is on console. Yeah, hello. So, yeah, we're all here monitoring, but okay, we really don't hope something will happen. But okay, in case we do have a safe mode, then yeah, we need to recover it.
Okay.
And since this is early in the pass, we have a full pass then to recover the spacecraft in case of need. But okay.
Cool.
We hope it will not happen, huh?
Wish you good luck.
Thank you.
See you on the other side then.
Exactly. Enjoy. Ciao, ciao.